Now let's take a look at this figure 17-16 from Stallcup's Electrical Design Book, Volume 2, and we're dealing with calculating the load for high voltage feeders in accordance with 215.2 B as in boy 1. And you can see that we take 90 amps at 100%, and the load would be 90 amps. And we're dealing with terminals per 110.40, which are 90 degrees C, medium voltage, 90. Now, notice 110.14C deals with terminals at 1,000 volts or less mainly. But here we pick up 90 degrees C as your terminals for high voltage over 1,000 volts and 110.40, basically speaking. Then notice you have 100% loading. There's no derating in accordance with 230.208B. When I say derating, if you had, say, a 100 amp overcurrent device in that switchgear there, panel board, whatever it may be, you wouldn't take 100 times 80% and just load to 80 amps. You could load those conductors to 100%. Now you may say, well, I've seen plans where the engineers put 125% on. Well, they're just providing a little bit of a cushion. But notice where these feeders are routed to transformers supplied at 90 amps nameplate ratings, see? And the feeder conductor shall not be less than the sum of the nameplate ratings of all transformers. And then, of course, you can see we're grounded to a driven rod, supplementing your water pipe in accordance with 250.52A1 and 250.50 of the code when you start providing and forming a grounding electrode system. And that's what this figure 17.16 is illustrating to the user of the code.